Hello and welcome to another episode of China Manufacturing Decoded podcast. And this is episode 158. This is Renaud and Andrew here. I'm going to be your host today, and I'm with Andrew Amenovin, the head of new product development in our company Sofeast. Hey, Andrew, how's it going?
Doing well, Renaud. Thank you very much. How are you?
Great. And today is an interesting topic because we've been working with a number of companies that develop a hardware product sort of as a support for their software or in complement to their software, and they come with a software culture. And then suddenly they're developing a hardware product and they have to sort of learn a lot of new tricks or maybe unlearn some software tricks. So the topic specifically is hardware product development tips for software companies, specifically for software companies that have been doing product development based on an agile approach. Okay, and very often it's a SCRUM approach, and it works great if it's well managed and everybody's happy about it. Works well with very well with software, but when you go into hardware product development, you need to be aware of the limitations of that. I'm not saying completely forget about it. No. But you need to be aware that you're going to run into some of the shortcomings. Okay, and you need to plan for it. And it's basically it's not going to be sufficient. Okay, so maybe first I can explain a little bit why, in general, software development tends to run on an agile approach. Okay, and what is the agile approach, right? So the idea is that the typical project management, sort of by the book, all right, is we're going to have this product, we're going to develop it. We have to agree with the different stakeholders and the customers and everything about exactly what to sell to them, what the functionality will be, and so on. And from there, at the same time, we need to evaluate what are the tasks going to be, what is the overall plan going to be, and what are the timelines, and what are the resources going to be, and working through a budget, and so on and so forth. Okay, and this has been the dominant approach, okay, to managing big projects, right? So if a city is going to put up a new airport or a new bridge or something, for sure they're gonna start to plan in this very traditional approach. Now, what software developers have found out is that it's not a great approach. Well, it has its own shortcomings, and we'll cover that. And when it's specifically software development, there is another kind of approach that tends to work in a very different way. Okay, and that's what they call the agile methodologies, the agile approach in general. It's kind of a philosophy a little bit. Okay, but it does tend to give very different results. Okay, specifically, you kind of set your resources and your timeline, and you say, we're going to do what we can within these timelines, and that's it. We're not going to try to work through every weekend and try to add more people and so on and so forth. No, the scope itself will adjust. And what it does is that it avoids the traditional pitfall of the traditional big project management approach, which is going to go over the cost, is going to run over budget, is going to take way longer. Okay? And if we look at airports, if we look at the most complex projects, it's like 95% of them are above budget and take longer, right?
Yeah.
Just because there's so many dependencies and so many things, and this one is going to go a little bit wrong, and that one is going to go completely wrong, and so on. And it's going to have a big impact, and there's going to be new issues that could not be planned and forecast and so on, right? So I mean, I'm sure you've heard of of some big projects like this that took forever, right? In France, we talk a lot about the new generation nuclear power plants. I mean, it's like 10 years behind schedule, and we don't even know when it's going to finish, I'm sure in the US you have these kinds of
Oh, absolutely.
famous examples, right?
Absolutely, all the time. I think there was one project, I'm not sure exactly what it was for. It was in Boston. It was called the Big Dig. They dug up like 5 stories into the ground, and they were
Huge
building.
tunnels, right? Yeah.
Yes, and it ended up taking forever to get that project done. Yeah, I
Right,
think
right,
I
right.
totally agree with you. It takes forever all the time.
Yeah, right. If you go from the Logan Airport down, and these tunnels are awesome, but yeah, it was a huge undertaking, right? So
Yes.
that's the sort of the pitfall. Okay, the problem with traditional project management is that you can plan, you can forecast as much as you want. You're going to be wrong, and you might be very, very wrong, right? So when it comes to software, it's been like 30 years back. It's been a long, long time in the making, right? So people came up with a manifesto for agile development, and they said, we need to completely turn it on its head and do it very, very differently, right? Don't try to have a big plan and like plan into the details and everything. No, you actually take the user needs, you break it down into sort of little blocks that they call stories, the little blocks that each one will create value as much as possible. Okay, you try to get as close to that as possible. And they call it a story because every time is like, okay, for that kind of user, this is the kind of user, and I want the product to do this because in my life or in my work or wherever I'm going to use it, blah, 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 and this is my need. And it really focuses the people doing the development work on, okay, this is really a need from that kind of user, and let's think of the right way to approach it, right? It tends to be better than maybe sometimes translating everything in engineering specifications and so on, and then people kind of lose track of what exactly the users want. Sometimes in these big projects, is very very common. So came up with this idea. More and more companies used it, and it has got to the point where I think I read some surveys, like most companies that do software development now do follow the agile approach more or less, right? And in most cases, it seems to be the Scrum approach that is most commonly used, most popular, and every company kind of have their own flavor of it, right? It's not all very by the book kind of Scrum. And they call it Scrum because in rugby you have this team, and then it's kind of messy, and they all go together, and they go like little by little, right? So that is that analogy that I liked. Okay, so in software, why is it? I'm going to cover that, and then we can go into right after that. What is the application for hardware, right? But first, it's important to understand, I think, why is it so popular with software? Because when you develop software, it's so important to see how the users are going to react and get the feedback all along. That you start by developing something, just one function of it, rather than the whole thing. Okay, now it's not an entire product, like it would not really stand on its 2 feet in the marketplace or anything, but it does something, and that something does already create a little bit of value for the user, and they put it in the hands of the users and they get some feedback. And this feedback is really, really priceless for software teams. They see how people interact with it, they see where they get confused and so on. They get better at it, and then from there, they follow what the users are kind of asking. So like, oh yeah, once we have that, then we really need that. And oh, by the way, it would be nice if it also did that. But this is the kind of insights that you only get when they already started to play with it, right? Not when you ask them, so, okay, imagine a product that would do this, 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 and then they will say, oh, it would be nice, ABC. But once they start to use it, they actually say, well, okay, but this is not that valuable, but actually that would be really valuable, right? And that doesn't work very well, and so on and so forth, right? And actually it's brilliant at that. So that is actually very valuable. Oh, we find it's great to use the software like that. Okay, then software goes in another direction, right? So the software is great. What kind of goes out the window, as I mentioned, is the the idea of the initial planning and the big plan and the big, like budgeting for resources and all the tasks and all the, doing a Gantt chart and a whatever they call it, PERT kind of charts and so on and so forth, right? To see, okay, this is the critical path. We need to be careful. We need to do this. And then these are some other supporting things. If this is late by more than 2 weeks, then it will impact the other tasks, right? There's a lot of planning. So all of that kind of goes out the window. But the problem is that one thing that also goes out the window is documentation of the needs and the requirements and sort of the agreement of different stakeholders. And that also is a problem for software development. If you develop something for like for the military or some, I don't know, for medical devices, or this is not going to work. Like through regulatory and other sort of requirements, this is absolutely not allowed. Okay, so even for software development, there are some limitations here. Okay, depends what kind of software you develop. But then for hardware, actually what's interesting, and Andrew and I have been looking into this, right? It's been applied in sort of slightly different approach, slightly different flavor to hardware product development, right? So I think both of us, we had a look at the same book, Scrum for Hardware Design by David G. Ullman, okay? Which is nice,
Professor David Ullman, yeah.
Right. What do you think? He takes some good examples, he makes some good points, right?
Well, I think so. You and I being hardware engineers ourselves, we both looked at this, and I actually have a lot of respect to Professor Ullman, and checked out, he has 2 books. One is called The Mechanical Design Process. Another one is that he's written is Scrum for Hardware Design, which you and I were very interested in. We kind of looked through that whole thing. And one of the things that he talks about that I found it very interesting, because it's really true. I kind of agree with him, being a hardware engineer, that, applying the Agile principles to hardware design is not easy. It doesn't mean it's impossible. Actually, David thinks that it's a great thing and should be done. So he's not going against Agile, and we are not neither. But what we are talking about here is that it's not going to be as easy, because basically it's hardware. It's not software. He talks about 13 points that really make sense, I think, and that, when it comes to hardware, it's not exactly like software. And so people who are designing hardware must be aware of that. Otherwise, this conversion will not work. One of the things that he talks about is less modularity when it comes to hardware. In software, it's totally natural and normal for having modules of codes and software. But that's not exactly the case with hardware. You actually have to design and create modules, and it doesn't come natural. And the second point he mentions is design cycle. Design cycles are really long in hardware compared to software. I mean, we could have a design cycle that could be 6 months, depending on what you're designing. And some, I think, I don't know this for a fact, but Apple design cycles for each one of those mobile phones, I think in excess of 10 months. So yeah, it can happen. And then the point is that design cycle needs to be taken into account. Number 3 that he talks about is high functional independencies in software, which that makes sense to me. Everything that we do in hardware, it's totally different. You got to have form and fit and function pretty much work together in hardware to be able to test the device, right? You couldn't be just saying, well, let's just forget about the functionality. As long as it's the form and fit is good, then we're good. No, it doesn't work that way. So you have to have the whole system, form, fit, function. But I guess That's not the case in software. You could have, certain modules be tested individually, separately, and
Yeah, right. You could have the front end
yes,
designed to have like, okay, this is the user experience with this UI interface, and we'll do the backend code later or something. Yeah.
exactly. And again, I'm not a software engineer, so don't want to necessarily get into any kind of discussion with that. But generally speaking, what he's talking about makes sense to me. Number 4 that he talks about is, you could write and rewrite codes in software over and over again, correct and keep going. You making big changes in and redesigning in hardware is very costly. It's not so easy to do such a thing. Number 5 that he talks about, when it comes to software coding, you have pretty much same level of specialized people, but in hardware, you really need specialty engineers in certain areas to be able to have a good design. You can't have like a part of the design be done by an engineer just graduated and another part by a seasoned engineer. And everyone has to be a specialized designer in hardware side of things. Then he talks about typically it takes longer time for prototyping, for example, for hardware. Whereas in software, you could probably write a few codes in a week or two, and boom, you're done. Or at least you got the rough prototype showing up how the functionality works. And that makes sense to me, right? Because you have to actually, in hardware, you have to do some planning, then initial CADs, and then you have to buy the parts, and you have to have the resources and tools to be able to do the actual design. And we do it all the time, right? So we know how painful that is, prototyping.
Yeah, it kind of works. It doesn't look too bad and so on, right? In software,
exactly.
Like when you talk really about prototyping, very often it might even just be a UX designer in Figma putting things together, pop, in 3-4 hours. Okay, this is the way it will work. You see, you click here and then you go there and then you go there. And if you click here, you go there. Okay, nice. Very different.
Yeah, totally different way of mindset. And then, of course, he talks about cost. Cost of making changes in software is just designing to making changes, code changes. There's not a lot of cost involved, time of the engineer and so forth. But that's not the case for hardware. As soon as you make a change, you might have to buy a whole new module or chip, or you have to do a PCB redesign. And all of these not only take resources, but really take a lot of time and cost to put it back together again and make those changes. And then he also talks about, hardware is more demanding range of operation. There's a lot of things that you have to do, that it takes a lot of time and resources, where in software is not exactly the same way. A lot of things can be done possibly by minimal resources. Yeah, again, I am not a software engineer. I'm just talking about some of the points that seems reasonable from what David is talking about in his book. And then the number 9 that he talks about, different test demands. That makes sense to us, right? We do a lot of hardware tests, and software tests and hardware tests are so much different. For software, you just put the program, you just need a computer and or a server, and you keep, running that software over and over until you have a failure. But that's not exactly the case with testing hardware. You need equipment, sometimes very expensive equipment. Some of those test equipment that test, for example, RF or mobile phones, each one of those equipment costs like millions of dollars, just equipment. And then they're very, very complex and sophisticated equipment. You need specialty, well-trained staff to know exactly what they're doing, or else test data will not be valid. So testing is very demanding for hardware, I think, versus software.
Software also, you need some people in teams that are, not, when it's not a tiny team, there will often be a QA person who will, be given whatever 1 or 2 days to go through a certain number of actions manually, right? And then over time they automate, maybe with validation testing, but sometimes it's more like the function itself, unit testing, right? They have all kinds
Yes.
of testing also, but it's quite different from hardware. Yeah, that's for sure.
Right. Then the other thing that he mentions that makes a lot of sense is the fact that when you're going through the hardware development life cycle, you're going through a lot of processes that you can't skip. And you can't say, well, let's do manufacturing before design. So you have to do design, manufacturing, test, deliver, and support. All of these need to be done in certain order. But apparently in software, you can skip certain orders and, maybe work on some area first and then come back and do some other areas. Is that the case, you think?
Yeah, I mean, you need to work much more, how to say, sequentially. You need to plan more.
I think so. Yeah, I think so.
Yeah.
Mm-hmm. Then the other couple of other points that he makes is that for hardware design, you definitely need very clear specifications. If you don't have those specifications clear, which are major challenges, and you're trying to translate those into Agile, it's very difficult. I suppose in the Agile, you get stories, and these stories have to be translated into some kind of specifications, technology. But even in the hardware, you have to have technologies and systems and specifications that all kind of have to be translated into how stories work. So it's not quite easy.
Right. Yeah, these are good points. Yeah.
Yeah. And then the last 2 points that he makes, one is that higher difficulty proven a task is done. And us engineers, we never really are satisfied, right? We keep updating the design and we never really know when to stop. And that's really one of the key issues with hardware. You keep improving and you don't know exactly when you're done. But in software, it's not quite like that, I guess.
Yeah, well, I'm not really sure. I mean, software is never done. Once you put it in contact with people anyway, right? There's always requests for this and that anyway. So, but when it comes to like saying this is done, we've put in place these functions, the promise, yeah. Maybe that's what they mean, yeah.
Yeah, and one of the last items, number 13, that he mentions that in Agile, the Agile process basically encourages to build, measure, and learn in philosophy. And he thinks that this doesn't actually work well when it comes to hardware because, you'd pay a higher price for premature commitments, premature hardware. And so all in all, looks like, whether you agree or not, some of these definitely make sense. And I think that he has a good point. And it seems that if you try to convert and run your hardware in an Agile process, you probably should know exactly what you're doing. Otherwise, you could run into some serious challenges.
Right. Yeah, and then, so I think we made a list of 8 points that companies that are used to running Agile for software development tend to overlook, and their projects tend to suffer because of that, right? So let's go through these points.
Yes.
So first one, and I alluded to that earlier, is that in traditional project management, you spend a lot of time planning and documenting the requirements and making them specific and so on. Okay. In Agile product development for software, they try not to spend a lot of time on these things, and they don't try to be exhaustive. They don't try, or let's say that they put less resources, let's say, into trying to be exhaustive and really cover everything nicely and completely and so on. Okay. But when you are designing a version of a hardware product, and let's say it's your version 1, right. Well, you can't sort of keep it in the back of your mind, no, you get to start documenting it, right? Yes. That's why phase 1, every time we see, okay, this new project, the NPI process, where are you? Phase 1, do you have a list of the functions? If possible, in the form of a user manual? Do you have a list of requirements for the product? Do you know where it's going to be sold? Do you know what kind of applications and the compliance requirements? Yeah. What is reliability, durability important? You need to know these things from the beginning. Does that make sense? Have you seen any team doing a good job going around that?
No, I totally agree with you. I think a lot of times, as soon as the prototype, as we discussed, prototyping takes a long time. And sometimes either the material arrives late or design functions, elongate because they had to make many changes. And basically, the project runs out of time. And here it is, close to production deadline. And all of a sudden, the reliability team and testing team comes in and, hey, can we start testing? And that's when they do the shortcut. Why don't you just do this one test and the rest is good enough. We don't have to do it. Why don't we do the reliability test, at the end, just before production, and we'll just run one test. And then they find issues and they start justifying no need to fix and known issues. And why don't we ship a few? We'll fix those later. And those are the kind of things that eventually, causes huge headaches for the companies or the owners of the product.
Oh, they often go out of business because they have bad feedback from the market, because they have people complaining. They have people, returning the products, calling for the warranty and everything. You have distributors getting worried, or e-commerce, like Amazon and so on. When they see these kind of things, you don't score points, let's say, right?
Yeah.
But also, if that's not very, very clear in the minds of the people who source the components, the people who work on the engineering design, are they going to make big mistakes? For example, if it's not clear what the compliance requirements are going to be, they're not going to care about that. They're going to say, oh, whatever, we'll send it for certification later, and that's it. And then you don't take maybe a pre-certified module. You don't ensure that you pick, I don't know, for example, if it's for food safety materials, you don't pick a material that's already certified, so you will have to do tests. Oh, guess what? You have 5 parts in contact with food or beverage times 3 colors. Well, that's going to be a lot of testing to pay.
Oh, yes.
That's going to be very expensive. So you make these mistakes and then you really pay them very bad. And in some cases, wow, if you have to develop to certain very specific standards, for example, you need to take into account functional safety or from the start, all throughout, right? I mean, you're just not going to be compliant. You're going to have to actually start development again from scratch, right?
Yeah, so, I think you made a really, really good point that I think maybe we should mention it to our listeners, and that is the compliance cost. A lot of our customers that are basically small companies to big companies, they sometimes forget the fact that some of these tests actually cost a huge amount of money, maybe even more than the development cost of the product. And so what they do is that they totally forget about those costs. And then here it is, we're about to finish the prototype and we got to do compliance testing. And as soon as you mention the quote on the compliance, they pretty much fall on the floor. It's like, oh my God, no, we don't have that kind of budget. How are we going to do that?
Well, not to mention tooling, because that's the other.
Oh yes,
the other big.
That's another good one.
Yes, I don't. If you try to, there's some fancy products like Have you heard of the juicer roll? That was kind of hot, especially in Silicon Valley, maybe 3, 4, 5 years ago.
Yes,
they had like 20 different custom design parts internally. It was nuts. It was really complicated. It was really expensive. They spent all their budget on before they get to the end of tooling, I guess. So you get to be careful. You get to really work, do what we call, what everybody calls design for manufacturing and assembly, based on your objectives, right? It's all
Exactly.
about, again, back to design for X, EFX. So that's the first point, planning, documentation, don't skip it. You have to do it. And also, as you do the development, you keep it updated, because you might think of new things and so on and so forth. You might decide to take it left and right. Now, you might do agile product design for hardware. That's fine, but you need to have sort of what we call phase one, documenting all that, doing a little bit of initial research and so on. Then when you do your proof of concept, and then when you do the engineering design to get to prototypes and so on, you can be organized, for example, in a SCRUM approach with a little bit of adjustments, but relatively close, yeah. But you need to have sort of some milestones and some checkpoints, going back always to the big risks and the big things to take into account. You can't just focus on user stories, which is, sort of, okay, let's do a sprint, whatever, 3 weeks, and let's show it to some users, let's get some feedback, and then let's plan for the next cycle, another 3 weeks, and so on. You do this in a very myopic manner, and you might really lose track of some very, very important topics, right? That's what we mean. Going on to point number 2 is that once you get to a final prototype that looks nice, works as you need for version 1, you freeze the design. You validate it, you test it, and so on. You get user feedback, etc. Okay, you validate, you freeze it. You don't keep going. Now, software companies are infamous for that. They keep adjusting things and so on. But then you need to bring hardware and software together and validate the integration, right? And you really need to freeze the design. Am I right?
Absolutely. At some point, you have to kind of look at this whole thing as, okay, we're good enough for this version of the product. Let's just push all the other upgrades to the next version. I think there's always room for improvement, right? So you could be going on and on forever. And honestly, I think that works for hardware and software also. Both are engineers, and engineers are never satisfied. They always are improving. So at some point, project manager needs to put his foot down and say, well, enough is enough. We need to ship this product, and let's freeze it, the design, and at a point, and start testing, and then fix the bugs and run it through production. You make a really, really good point about this whole thing, I think. And I think that, yeah, at least first timers definitely need to take note. One thing I noticed that, I think that when it comes to Agile for hardware definitely works. It's just that can't be exactly like how the software is done. There has to be a kind of hybrid of how it used to be done, but then take some really great notes and ideas from Agile and so Agile for software, which a hardware could benefit, hardware design.
Absolutely. And then, that leads us to point 3, which is quite close to point 2, is that you need an engineering change management process, right?
Yes.
As you start to work with some other parties, you start to work with a contract manufacturer, you will, whatever, they will, maybe put together the final prototype. They will start to work on the tooling and so on. And then they might find ways to maybe make it easier, make it faster, whatever. There needs to be a process. Remember, product design is frozen. Now, it might have to change a little bit to accommodate for the manufacturing process, testing process, and so on. But you need to keep on top of what happens, and there needs to be an approval process, so you know exactly what happens, right? Or you're going to have someone in their corner make a change, that's not going to be properly validated, retested, and everything. It might have a lot of impacts that person did not think of, and that might have catastrophic consequences, right?
Exactly. And that has happened many times. You and I see that every day when the key designer forgot something, got distracted, and boom, you run into all kinds of issues later.
Yeah, for example, they find out about it later and they make a little change. They just push it and other people don't know about it. Yeah, but it could come from anywhere. Yeah.
Yeah, you mentioned something really good, and I just remembered that change management can't be done always manually. If it's a small project, it's okay. But if you got a huge PCB, big project, and you got a lot of people working on it, honestly, I think that you probably need at least one person responsible for it, and you need some kind of software.
Yeah, sure. There's a number of software that can run that. The next point is supply chain visibility. So hardware comes with a bunch of components, right, that come together into the final product. And you don't have to manage that for software, right?
Yes.
But suddenly, and maybe you still view it as your software product that is mounted on a piece of hardware so that it delivers more value. Okay, well, now you have to also manage a supply chain. And that's kind of new to software people. But if you you fall prey to a trading company or a manufacturer that acts as a trading company, doesn't give you any visibility, that would become painful at one point. And you might have to switch away from that manufacturer to another one that might be really costly in terms of money, in terms of time, and so on, right? So you need to plan for that again. And you need to identify the critical components, the PCBA, the display, the battery, whatever, right? What is expensive and what is prone to failure, what is really important to differentiate your product, right? So you need to have a very clear idea about these ones, and you need to be very clear, okay, where is it made? Like the custom design plastic enclosure, that's a classic one. And the tooling, where's tooling made? I mean, you need to know all these things. You need to have a proper contract also to manage these people and to have visibility, but also to make sure they hold their end of the bargain. Yeah, you need to plan for how to manage the supply chain, and you need to implement that.
Totally.
That's a big one.
Sure is, yeah.
Yeah, because again, just to make it very, very clear, you have one bad component or one component that you cannot make, that you cannot procure. Sometimes you cannot just skip this one and buy another one to replace.
If there is a component shortage in the world, or there's some kind of logistic issues, these components are coming only from China. And for example, right now with issues that are happening politically, around the world, I think these could pose all kinds of issues.
Yeah, exactly. I mean, look at the number of cars that are not made because there's not enough chips, right? Look at difficulty just of procuring even Raspberry Pis and things like that. It's pretty serious, but it's not just electronic components; it's everything. So when you look at the very big companies like Apple that really have the budget to do it right, well, they double source everything. The little plastic insert, the screws, everything.
Right.
They have, everything when it makes sense, right?
They have to stock up some of these components, which goes totally against the just-in-time, right?
Yes, yes. Sometimes what Apple has done is, they have like multi-year contracts, obviously for semiconductors with TSMC and with the glass manufacturer. I think it's still Corning, with some others. They sort of lock in the capacity and they put money down. They've even purchased a lot of the production equipment for that. So you have to manage the supply chain. Okay, you have to keep it on your radar, basically. Okay. The next one is that you will need a quality function. Okay. And it's not just about doing testing. Like in software, what they call QA is what we would call QC, right? It's just, okay, I got a product, I'm going to run the testing and I'm blah, 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 right? And of course, the testing in software is kind of preventive also for the future because a lot of it is automated. That's great. You will catch the issues very early on. That's part of quality assurance. Okay, I get that. But when you talk about manufacturing, wow, you really need to do proper risk analysis. You need to validate the suppliers of the critical components. You need to do a whole bunch of things, right? The engineering management
Exactly.
process typically, you need to follow up on the issues and get to the root cause of them. Wow, it's a lot of work. Quality people are going to be very busy, right? So you can't really skip on that function. Let's say if you're just 1, 2, 3 people, okay, you need to think of the quality function. You need to have someone do some of it, right? You need to specify, this is what I want, and I want it that color, not that color, right? Just at least the basics, right? I can accept on the top surface that's very visible. I can accept this kind of surface, so this kind of dent, but no more, no worse than that. Okay, someone needs to say that and document it. Okay, and then when you start to grow your team, you will need to have a quality person for sure. Okay, and that's something that a lot of companies are kind of putting aside, but quality and compliance at this stage, usually you have one person who handles both, right? But that's really important.
I think you make a really good point here. A lot of people may think that quality function is just checking something, but that's not exactly it. I mean, you're not checking one thing. You're checking the components and doing inspections as soon as the parts come in, and you have to do inspection and checking while they're being assembled. You have to check the product and inspect it when they are tested through the line process. Then when they're packaged, you have to check and make sure all the parts and adapters, for example, or anything that needs to go with in the box are going to be in the box. You have to weigh the box. You have to do AQL at the end to make sure that predicted defect rate is within the acceptable range. There's just so much into quality and checking the product that I think quality is underestimated by some of the companies who are developing and making products.
Yeah, if you want it to come out consistently good, you need a quality function. Okay, that's really important. The next point is, as a software team, you tend to see your source code as something very, very important. The software code, that's great, okay, but all of the mechanical and the electronic CAD, computer assisted drawing design files are just as important. The schematics of the PCB and the drawings and so on are just as important. And the BOM, the bill of material, is as important. And the bill of material has the list of the components and their sources and their minimum order quantity and the lead time and the price and all kinds of things and what validation they went through and so on and so forth. You can't not have that, right? If you don't have that and if you're not on top of it, it's part of your product, really. It's the design of your product that you don't have in your hands. That's really bad.
Totally.
Am I going too far here, or?
No, I think you're right on the ball. I mean, this kind of ties in with a little bit with documentation, change control, and having detailed tracking of where you are with your bill of materials and drawings, updated schematics. I mean, imagine if someone drops the ball and uses the wrong drawings. I mean, what is it going to happen? You can just imagine. Or if you got the bill of material and one critical component was forgotten to be ordered, that is a long lead item. Or it was ordered by a company, like McMaster, as opposed to a real manufacturer. I mean, all kinds of huge things can happen that you really need to have a very seasoned project manager to really catch these issues from all kinds of levels. So we're talking, a good seasoned project manager would understand that, hey, this engineer is junior level, he may not know. So let me see what is he exactly doing. Not necessarily to micromanage or pick on him. It's just to understand, is he doing the right thing? If not, let me educate him, because one mistake on his part and everybody trusts him that, okay, he's doing everything right. Next thing you know, hell's on the loose, and everybody's pointing fingers and crying, what are we gonna do now? Then if we make a change, or if this part doesn't arrive in the next couple of weeks, we just lost the market share. So
and the stakes are higher. Yeah, the stakes are higher. Oh, we ordered $20,000 of these batteries and they're no good. What do we do now? Or even worse, we ship the batteries, but now we find that they're not.
Well, one of them exploded, and there went your trust.
Yeah, or the charger went up in flames or something. Oh, what do we do now, right? The stakes are much higher, and the timelines also are very critical. I mean, you have to have the products on the shelves the week after Thanksgiving if you want to do a good Christmas season, right? And then before that, you need to ship it, 6 weeks before, which means the ex-factory date, maybe say 7 weeks before, which means past final quality even before that, and production was finished, and right? And if you're a little bit late, then then we're going to pay an extra $30,000 just for airfare. Ouch. Or ouch. It's not going to be on the shelves. We're going to have penalties, or all kinds of bad things like this.
And again, what you just mentioned, it just shows the difference between software and hardware. In the software, of course, missed issues could pose a huge hurdle. I understand that, but when it comes to hardware, I think one small mistake can translate into huge problems with respect to deliverables or testing or meeting the specifications or meeting the demand. I mean, the mistakes are, like you said, very high stake in hardware than I think software.
Right. Yeah. An analogy for that would be, in software, you're going to shoot at another ship. Let's say, okay, let's go back 2 centuries. You can start to shoot, and then you see where your bullets land, and then you adjust and you keep shooting, and then finally you start to hit the other ship. Boom, 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 boom. Right. In hardware, you have a huge cannonball. Then you need to wait and load it patiently, and then do all your calculations and everything. And then boom, and then you have another a long time before you can shoot the next one. So you need to be much more deliberate about how exactly to calculate the trajectory, the distance and everything to hit that other ship.
Totally. Yeah, makes sense.
So let me see. So just to finish, we still have 2 bullet points. Number 7 is product reliability, and we talked about it a number of times on this podcast. Also, what we noticed with a number of our customers who come to us and they've been doing software for a while is that very often software, they get paid with the software as a service model. And then when they add a hardware piece to one of their product or a new product, they tend to also sell it as a service, product plus software as a service, basically.
Right.
So they still have that business model of delivering the product and then getting paid over time as the product delivers value, right? And if you do that, and a lot of your products fade after 6 months, after 1 year, well, you're not going to keep getting paid for those. You need to, send another for replacement, and it's expensive. Now, if your products last for 4 or 5 years instead, I mean, the difference in terms of profitability in the mid to long term is staggering. So
absolutely,
reliability maybe is even more important than when you sell something with a 1-year warranty and you want to make sure that you don't have too many returns and blah blah blah, and the industry norm maybe is 3%, 5%, or depending on the channel. Okay, no, it's with software companies, sometimes they might not realize it, but reliability is actually even more important for them with their business model.
Yeah, I mean, take an example, a car, that must at least be functioning very reliable for at least 10 to 15 years, you know? And what if all of a sudden within the first 5 years, and we've seen this happen in at least US car makers a few times, but the last one was with Toyota, right? They had a airbag issues. You recall what happened?
Oh yeah, it exploded. It actually sent some metal projectile into people's heads.
Exactly. And killed a few people.
Yeah, right. It was a Japanese, I forget the name, but like a huge company making a lot of, there's only like 2 or 3 major airbag manufacturers.
Yes, exactly.
Yeah.
I mean, that's a perfect example how you can underestimate product reliability and then take that product without perhaps testing properly or trusting the supplier too much, and then implementing that into your awesome Toyota product, and boom, all of a sudden you have unbelievable. It's more like a nightmare happening for Toyota. They lost huge business on that, not only in terms of a lot of people's trust in the product in Toyota, but also probably a lot of legal costs.
Oh yeah. Well, it's very, very, it's highly regulated, obviously. I think even when they do car assembly in the US, they have to have an inspector. It's mandated by the government to make sure the airbags are placed correctly, all the way until the manufacturing, the point where it's assembled into the vehicle. And then you can imagine all the hurdles on the design and the manufacturing of these airbags themselves. Yeah.
And the meat of this conversation, I would say, is that you can't look, and you made a good point on that, is that you can't look at a small consumer product that you can just do a drop test and you say, well, it's good enough. Right. You can't be thinking that way when it comes to reliability of an airplane or a car. You really need very specialized reliability engineers that will have to do parts count, prediction analysis, do a lot of serious reliability calculations to actually understand, the parts that are accumulated in that product, plus the whole product itself, the whole system. And that's why in those environments, they don't call them reliability engineers. They call them system analysts, because they really look at the whole product as a system, and they calculate the reliability, and they come up with reports on what are the risks and what are the rewards.
Right. And where to add redundancy and so on and so forth.
Exactly.
Where to add a fail-safe and so on.
Yeah, absolutely.
Vast topic. And the last one is product compliance. And this touches on product safety, which we just touched on with product reliability, obviously, because often poor reliability leads to safety issues. But product compliance is something you need to plan from the start. And I actually already mentioned that earlier in this episode. You need to know what standards, what regulations you will have to comply with, because it will impact what suppliers you can work with, what materials you need to pick, what components you need to pick. Should they be pre-certified in some way? Should you, how to qualify them? And then when you are building your product, in your own design, what are the good practices that you absolutely have to follow? Because you can't do all that work and then get the tooling in place, and with the parts of tooling, you do an engineering build, send it to labs for certification, you wait for a few weeks, you pay thousands and thousands of dollars, and then you fail. And you wonder, wow, how come we fail? Well, it's way too late to start wondering about these kinds of things. This should be planned from the beginning and all along, right?
Absolutely. And I think that we have some information about compliance in general for our listeners. In case they are interested, we can definitely put a link in there from previous podcasts that talk about when is a good time to do compliance testing, how much it costs roughly, and the whole planning of the whole compliance. I think they could benefit from that
Right. We're running out of time, so this is a big topic and interesting topics.
Definitely.
Thanks a lot, Andrew, for joining me on this one. Yeah, we covered it quite nicely. So we'll let our listeners think about it, and if they are in that case, hopefully draw some lessons from what we discussed. All right. Thanks a lot, Andrew.
Thank you.
Catch you next time. And to the listeners, thanks for listening. By the way, give us a 5-star review if you like the content, if you think it's helpful in whatever application you use. Maybe even leave a little bit of a comment just to make us feel good about putting this out every week. Having said that, talk to you next week.
Thanks again for listening to this podcast brought to you by the Sofeast Group. We're on a mission to provide you with everything you need to manufacture effectively in Asia, including inspections, auditing, new product development support, contract manufacturing, 3PL warehousing and fulfillment, and much, much more across Asia's key manufacturing areas. Visit us at sofeast.com, that's SOFEAST.com, to learn more and get help. If you've enjoyed the podcast today, please do rate, review and share because it will really help others discover us too.